Dear students, we know that our Earth is not uh, exactly spherical, but it is bulged at the equator and flat at the poles. Therefore, radius of the Earth is large or greater compared to the radius at the pole. So, uh, we know that acceleration due to gravity is inversely proportional to the square of the radius of the Earth. Therefore, acceleration due to gravity at equator is comparatively less than the acceleration due to gravity at the poles. Therefore, uh, when we move from equator to the poles, gradually acceleration due to gravity value increases, and uh, obviously the mass of the sorry weight of the object increases when we move from equator to the poles of the Earth. So this is the variation of acceleration due to gravity in accordance with the latitude of the Earth. Also, the value of acceleration due to gravity varies with respect to the rotation of the Earth. As the Earth rotates about its polar axis from west to east, the centripetal force comes into play, and this affects the weight of the body. On solving the actual weight and uh, current weight of the object or a body, there comes into play the value of latitudes. That means the angle of that latitude in which the object is at. So the effect of latitude also comes into play to change the acceleration due to gravity at that latitude or at that place. So if we consider omega as the angular velocity of the object and the latitude of the place is phi, then the new expression for acceleration due to gravity can be written as like this. So new acceleration due to gravity at latitude phi is equal to g. G is the acceleration due to gravity on the Earth's surface at equator, minus r. R is the radius of the Earth, omega is the angular velocity of the object, and cos phi is the cosine of the angle of latitude. So as the phi increases, cos phi decreases. We know that from cos 0 degree has maximum value and cos 90 degree has 0 value. So as the value of phi increases, cos phi decreases. Therefore, whole expression for g will decrease, and vice versa. So at equator, value of latitude phi is equal to 0 degree. Therefore, acceleration due to gravity at equator is equal to g minus r omega square, and at poles phi is equal to 0 degree, that 90 degree, that is latitude is equal to 90 degree. Therefore, acceleration due to gravity at the poles is equal to direct g, since cos 90 degree is equal to 0. Thus, we have seen that at equator, g minus r omega square, and at poles it is direct g. That means it is on the surface of the Earth. So we have seen that gradually acceleration due to gravity increases when we move from equator to the poles, either it is south pole or north pole. So topic variation of z with respect to latitude or rotation of Earth is not included in textbook. but it is important from the entrance point of view, so I have included in my video. So dear students, if you think my videos are useful, then like and share, and if you have any queries or doubts, then comment me. So now let us find out the vector form of Newton's law of gravitation. So we have considered 2 point masses m1 and m2 in a Cartesian coordinate system, that is x, y, z. The position vector of m1 and m2 are written from the origin of the Cartesian coordinate system. So it is r1 vector and r2 vector. So this is the Cartesian coordinate system, and the position vectors for m1 is r1 and for m2 it is r2. The separation between the 2 point masses is r vector. So the force acting on mass m2 due to mass m1 can be written as from law of gravitation. It is F equals z m1 m2 by r square, where z is the gravitational constant, r is the separation between the mass m1 and m2. This force is in the vector form will be F vector, that is force vector, multiplied by this scalar quantities multiplied by a unit vector. Any unit vector multiplied to a scalar quantity gives the direction of the figure out quantity. So here this unit vector gives the direction of the force. This minus sign shows that the force is an attractive force. So force is negatively directed or oppositely directed to the direction of the position vector r or separation vector r. This is called separation vector. So both are opposite to each other. So taking negative sign in front of the constant, gravitational constant, we have this unit vector. So unit vector is what? Unit vector is the ratio of the vector to the magnitude of the vector. Ratio of vector to the magnitude of the vector. This is called unit vector. So therefore we replace our unit vector by r vector by r. So we have expression of force is equal to F vector equal minus gravitational constant product of mass m1 and m2 by r cubed multiplied by r vector. So this expression of force is for the force acting on mass m2 due to mass m1. So we can write here notation, it is F21. So force acting on mass m2 by m1. Similarly, we can write the expression of force on mass m1 due to m2, the force acting on mass m1 due to m2. So here m1 and m2 are same, only the position factor is different. Therefore separation here we are interested only in the separation of m1 and m2. So here also the separation will be r vector. So we can write the expression of force on m1 by m2. So it is obvious that F12 vector, that means force acting on mass m1 due to m2, is equal to minus F21 vector, that means force acting on mass m2 by m1. So as the force are attractive force acting on each objects, therefore they have equal in magnitude but oppositely directed to each other. This also follows Newton's third law of motion. So the gravitational force between two bodies are equal in magnitude and opposite in direction. So this is the vector form of Newton's law of gravitation.